All right, hello and welcome everyone. Thank you for joining us. We're going to wait a couple more minutes for people to have time to join. This webinar is being recorded and I'll be monitoring the chat over the course of the webinar, so please put any questions and comments that come up along the way in there as well. All right, welcome again, everyone. Now that we've got quite a few people here, we're going to get started. This is the first of hopefully many virtual and in-person educational opportunities that will be presented at Whiterock Conservancy this upcoming year. We have people joining us from all over Iowa and several states as well today. Many of you may be already familiar with Whiterock and its mission, and others may not. Whiterock Conservancy is a 5,500 acre land trust located in Coon Rapids, Iowa, about an hour west of Des Moines. We are open to the public for recreational use, such as hiking, mountain biking, equestrian trails, ATV rentals, fishing, camping, and housing accommodations. Whiterock is involved in conserving and protecting Iowa's natural resources through land management, as well as demonstrating sustainable agriculture. Altogether, Whiterock's mission is part conservation, sustainable agriculture, and public recreation and education. To get involved with Whiterock Conservancy, you can donate, volunteer, come out and visit, or follow us on our social media pages. You can scan these QR codes with your phone if you have it on you, or I'll be also putting links to the website and social media in the chat. We are joined tonight by Kathy Woida, who is NRCS scientist and author of Iowa's Remarkable Soils. After this webinar, if you are interested in learning more about soils here in Iowa, her book is a great place to start. Today, Kathy will be presenting about soil properties, biology, soil degradation, and soil health. As a reminder, please put questions and comments in the chat and remain muted while Kathy is speaking. There'll be time at the end to go over questions. I also have a poll for participants to fill out at the end of the webinar, so please hang on for a few extra moments if you can and answer those questions. And now I'll pass it over to Kathy.
Welcome, everyone. Thank you so much for joining us here at beautiful Whiterock Conservancy, where I've actually been staying for the last week. I'm here to talk about soils, and I honestly, truly believe that soils are at the very foundation of the health of our land, our water, our ecosystems, and in fact, to a large extent, the health of our economy in this state. So whether you know a lot about soils or don't know very much at all, I hope that each of you will take away something from this webinar that will help you understand the challenges that we face and also some of the reasons we have hope for the future. First of all, a little bit about myself. I spent my entire childhood close to the land. I grew up on a 160-acre farm in northeastern Michigan, right here, about 10 miles from Lake Huron. And the main crop is potatoes, but there was also grain, hay, and a small dairy herd. And it was homesteaded in 1873. Is that showing? Okay. It was homesteaded in 1873 by my grandparents, or great-grandparents, sorry, who emigrated from Poland. So it's been in the family 149 years. So we're planning a big celebration in another year. 5 generations have lived and worked and raised their children on this farm. My great-grandparents, my grandparents, my father, and of course my mother, who's not in this photo here. And then my brother took over the farm. And then more recently, his son, my nephew Joseph, or Joey, took over the farm. And as you can see, I grew up in a pretty large family. So you can imagine it's a pretty hectic household. So I kind of got used to taking a lot of walks by myself. My mother called me the independent one. And so I roamed the land, the pastures, the fields, the woods, time and again. And then, after I left home, I've lived in 6 states and 13, I think it's 13 cities. And everywhere I've lived, I felt a bond with the land. I've been outside. I've spent much of my time, both as a geologist and in my personal time, on the land. So I do feel a bond with the ground beneath my feet. So in 1986, I went to the University of Iowa in Iowa City and worked on my PhD and finished up in 91. And I was working on a buried soil, but in the process, I took soils classes at Iowa State University. And it was during my research that I just became totally fascinated by soils, their complex beauty and phenomenal memories, really. I mean, if you know how to read the clues in soil, you can understand a lot about what happened in the past, thousands of years, in some cases with these really old buried soils, hundreds of thousands of years. So it is absolutely fascinating. I taught college for a couple of years, and then in 1993, I joined the Soil Conservation Service in Utah, first in Utah and then in New Mexico. About a month after I joined, the name changed to the Natural Resources Conservation Service. And in the Southwest, erosion is, pretty common because it's a very arid climate. It might get 8 inches in southern New Mexico, for instance, 8 inches of rain a year. But that might happen in 2 rainfalls. So it's very intense rainfall on a fairly barren landscape. And the other thing that I worked on were forest fires. So we would go in immediately after a fire, before the erosion began, to try to predict what the rates of erosion were going to be in order to help the planning process for sedimentation that was going to end up at the bottom of the hill, the bottom of the Piedmont, bottom of the mountain, to be able to quantify the amount of sediment that was going to happen because of that. So that was very interesting work. In 1999, I came back to Iowa, and it really was like returning home. I've always felt a real fondness for the big skies and rolling hills of Iowa. And I worked there with the agency until 2019, when I retired. Okay, so the topic of this webinar, of course, is soils. And NRCS soil scientists and geologists study soils. They sample soils in a lot of different ways. These are some of the tools, different kinds of manual probes. This is called a steps back saver, which is supposed to save your back. I'm not sure exactly how well it works, but it does help. Backhoe pits, and the soil scientists have these small pickup truck mounted Giddings rigs to get cores of soil. So these are some of the ways. As geologists, we would sample much deeper. The soil scientists typically go about 80 inches. And, as geologists, we were going 30, 50, sometimes up to 90 feet, and looking at the deeper geological materials beneath the soil. Here I am with 3 of our premier soil scientists, Jason Steele, Mark Levan, and Brian Dermody. Mark Levan has since retired. And here we were also able to do sampling, what we call undisturbed sampling, and get cores out of the ground. And this was always some of the most exciting time for me, because I just love to see what comes out of the ground. And, the deeper we went, the more interesting it got. Well, the other half of my job was evaluating soil erosion, both in fields and in channels, and characterizing the stability of channels. Are they stable? How are they going to be stable in the future? What has been their evolutionary history? And then predicting the rates of sediment as best as we could from the erosion that's happening. Later in my career, the last few years, I got involved with working with soil scientists on soil health, and that we're going to talk about that a lot in the rest of this webinar. So, erosion has been a problem in Iowa for a long time. It started with settlement and has just gotten worse and worse. And here you see a picture that shows a hilly terrain, and the light colored hilltops is because the topsoil is gone. And a lot of it ends up down here in the lower parts of the landscape, and some of it ends up being carried away to streams and rivers. And eventually, because of high rates of runoff, we get erosion of channels, both down, erosion of the bed, and erosion laterally into the banks. And then further downstream, there's sedimentation because the flow slows down, and there's a problem because it causes flooding, because the channel has less capacity. So there's a lot of issues related to soil erosion. the Soil Conservation Service, later NRCS, the mission to protect soil from erosion, it officially began in 1935 with the Dust Bowl. And there are currently more than 160 conservation practices offered to farmers, and they are partially paid for by your taxes. There's typically some kind of a cost share system involved for the farmer, where the farmer puts in a certain amount. But there's a lot of tax dollars going into this. I'm just quickly going to mention a few of these, and I know most of you are very familiar with terraces. You see them all over the state. We've been putting terraces in since the 1960s, thousands of miles of them. And the whole point of terraces is to interrupt the downhill flow of water, because as water flows downhill, the faster it flows, the more soil it carries off. And then the sediment collects up above here at the top of the terrace. But these are only designed for a minimum life of 10 years. Some are, I think, are up to 25 years, but so they do have a limited life, and they don't work forever, and they do require maintenance. Grass waterways have become a lot more common in the last 10, 12 years. And this is to prevent erosion of a gully on this low point in the landscape where water flows off the hills down into the low point. And if you don't have vegetation there in the winter and early spring, you're definitely going to get erosion. Others are contour farming has been in place for a long time. Most Iowan farmers do contour farming. That means that they're farming not up and down the slope, because then water can simply run down along the rows, but to farm on the contour. And riparian buffers are also becoming more common, thankfully, because they trap sediment, they trap nutrients, and they stabilize the banks to prevent erosion of those channel banks. And the last thing I'll mention is the CRP program, where farmers are removing highly erodible land and putting in perennial plants, native plants sometimes, and other grasses to protect the soil. Okay, so NRCS has done a lot, and honestly, I can't even imagine what our landscape would look like if it wasn't for all of these practices. But the sad truth is that after 160 years of agriculture, we're still not looking all that great. Because when Iowa Prairie was first plowed, there were 14 to 16 inches of topsoil. By 2000, that was half that. And the remaining topsoil had lost up to half its organic matter. And since at least 1982, when the first data were collected with the National Resources Inventory, Iowa's led the nation in sheet and rill erosion on cultivated land. We are #1 in the country for sheet and rill erosion, and I'll explain in a little bit what sheet and rill erosion is. We have 7% of the country's cropland, but we produce at least probably more than 15% of the country's annual soil loss. We're #1 in the state. I'm sorry, we're #1 in the country. So these are some discouraging facts. So sheet erosion is when a sheet of water is running down a hill, and then it starts to concentrate in these concentrated flow paths and creates rills. And the rills are small enough that they are obliterated during disking and tillage. But you can see here on this slide on the right how the upper parts of the slopes have lost the black topsoil, that black gold of Iowa, which has ended up here on the low points. And I'm not going to go into a lot of numbers and details, but in 1982, we led the country in sheet and rill erosion, and along with northern Missouri, I mean, you don't have to look at the numbers, just look at the map. I mean, it's this glaring purple bullseye on Iowa, where just tremendous rates of sheet and rill erosion. And this is an average. So even though here in north central Iowa, the rate may have been 2 to 3 tons per acre per each year, and this here, we're talking maybe, an average of 12 tons per acre. So that was pretty bad in 82. And then in 2017, this is what it looked like 35 years later. It's certainly improved, but we still lead the country. We still lead the country in the rate of sheet and rill erosion. A lot of improvement was made with the 1985 Farm Bill, and a lot of ground that went into CRP, that it helped that a lot. But again, we still led the country. Now, there's something called ephemeral gully erosion, which is the next step up for erosion. These are not simple rills. It's where a rill begins to enlarge, and they might be a foot deep, a foot wide, something like that. They're ephemeral. They're called ephemeral because you can disc them up or plow them over before planting. These show up in the, after the snow melts, and that's when you typically see them. So they're called ephemeral, but the problem is they're carrying so much soil that here the soil is collected in this ditch. And the nice black soil, that's where it sits, where it's not going to do anybody any good. So I think I've omitted to mention that if you include ephemeral gully erosion, it probably doubles the amount of lost soil on top of the sheet and rill erosion. Then there are also these classic gullies. A lot of the ephemeral gullies lead to channels. Most of them lead to a creek or a channel. And then these channels will also erode deeply. This is a 7-foot head cutter overfall in this channel. It's working its way upstream towards a county road. And this in Polk County in the Easter Lake watershed. And this is a project I worked on. So I'm having trouble seeing the headings. So what are the costs of erosion? Well, erosion is very costly. There's lost productivity, yields because you've lost a lot of organic matter in your soils. And the organic matter is what lends soil fertility. And also the soil is able to hold less water because it's the topsoil that really holds the water, the organic matter. So the soil is being degraded. Another huge problem in our state and elsewhere is the amount of sediment that's reaching our reservoirs. This is a picture of Lake Whiterock at Highway 14 during a drought year when the water level was very low, and you could see the sediment that's building up here. And it's really astounding that the average rate, if you average out the amount of sediment that's entering that lake, it would fill 7 Olympic-sized swimming pools every single day. Now, of course, it doesn't work that way. There's times of the year when it's much worse than other parts of the year. But if you average it out, it's 7 Olympic-sized swimming pools per day. In addition to that, when you lose your topsoil, you need more fertilizer. So then that means more nitrogen and phosphorus ends up in our streams and lakes. And that's a huge problem for water quality in Iowa. As you well know, it's in the news all the time. So despite years of efforts, we still lead the nation in soil erosion. Our soils continue to lose more organic matter every year, and that's bad news because organic matter is made up of 60% carbon. So we're releasing that carbon into the atmosphere, which is a no-no for global warming. And then runoff from fields is polluting our streams and lakes with fertilizers and pesticides. So about 10 years ago, NRCS started their National Soil Health Initiative. And NRCS did not invent the idea of soil health. There were farmers in Iowa, and there were organizations like Practical Farmers of Iowa, who are way ahead of NRCS, but finally the federal government was getting on board and emphasizing that the practices we've been applying to the land are great, but in a way they're a Band-Aid. All they're doing is collecting the sediment in one place or another, slowing erosion in some places, but the soil is just continues to get worse and worse. The two practices that I'm going to talk about today, and the two practices that are really encouraged by Practical Farmers, by NRCS, by Midwest Cover Crops Council, are no-till cultivation, where once the crop is harvested, it's left alone, all the residues left on the field. Then a cover crop is planted in, and then in the spring, the cover crop dies, and then the crop is planted. So you've got planting and you've got harvest, and that's it. You're not messing with the soil otherwise. The cover crops are planted in the fall, and they something that are there to feed the microbes, which I'll talk about in a little bit, and to cover the soil, give it a, as one farmer said, to keep the soil healthy, you have to feed it and give it a roof. And this is what cover crops do. They give the soil a roof. When you drive around Iowa in the fall after harvest and in the early spring before the crop comes up, there's so much bare ground. It's just kind of sickening to see all that bare soil just exposed to the elements. And it's not the way nature works. Nature doesn't leave the ground bare for 7 months out of the year. So these are the two major practices. In order to understand why lost my train there. To understand why these practices work, you have to know something about soil. And so a lot of different people have different ideas of what soil is. I like the one here where the quarry operator thinks of the soil as something to get rid of because it's covering the rocks that he wants to get to that are worth money. But for most people, that especially people that have never lived on a farm, don't know farmers, dirt is just something that gets on your hands and clothes. It's not necessarily a good thing. Well, in Iowa, we definitely had a good thing, and we still have a good thing. But we started with some of the best soils on the planet, if not the best. The best, most fertile soils on Earth are in the dark green here and here, as well as down here in Brazil. And these are the bread baskets, the bread baskets of the world. So we began with some fantastic soils. And the main reason is that at one time, 80% of Iowa was covered by tall grass prairie. This map shows the different grassland regions or ecoregions, tall grass in the bright dark green, and then midgrass, short grass. Tall grass prairie is phenomenal. I mean, as a matter of fact, I was just looking at a poster that they have here at Whiterock, and it probably goes 10 feet, oh my gosh, no, 12, 15 feet into the air, because it shows the upper part of the plant, the big blue stem, is about 5 feet tall. And then there's about 6 or 7 feet of root that's shown from under the ground. So the roots in prairies extend really deep. I mean, 6, 10 feet is not unusual at all. And those roots then, the smaller root hairs and parts of the roots decay each year, even though these are perennials, and add organic matter to the soil. So this is where the black gold of Iowa started. But there is a lot of variation among Iowa soils, regardless, even though most of Iowa is prairie. Differences in texture. I'm sure the first thing you notice if you pick up soil and rub it between your fingers is how much sand. Does it feel sandy? Does it feel clay, silty? Even though you may not be able to identify the soil type, you can feel that. Soils are different, have different thicknesses, color, and certainly differences in fertility. The texture is explained almost exclusively by the geology. Whatever geologic deposit or material the soil formed in is going to determine the texture. So here's one that formed in glacial till. This is material that melted out of the ice. And it's very poorly sorted, we call it. It's got particle sizes of all different sizes. So most of this is sand. These white and blue and black are sand particles. So there's a lot of sand in this. This is a loam. Here's one that formed in loess. You all have heard of the loess hills. This is wind-blown sediments, so they're very fine-grained. There's a few sand particles here, maybe here, a couple of them, but for the most part, it's all silt. So that's because of the geology. Topography certainly plays a role. We generally have thicker soils up here on the summits and down here where the eroded material ends up. So those are thicker, and on these shoulders, you've got erosion, so the soils are thinner there. But I don't want to talk too much or spend too much time on that. What I want to talk about today is the most critical factor today in today's soils is the human impact from land use and management. So we're going to focus on agriculture because 70% of Iowa is cultivated land. It's row crop basically. And so that's a huge portion, more than any other state. And so in terms of agriculture, the two most important things about a soil are components, are its internal structure, which I like to think of as the soil's architecture. And then secondly, the biology, the ecology of the soil. So we have got the physical property here and a biological property. First of all, let's talk about soil structure. Well, there's an official definition. It's a natural organization of the particles into aggregates, which soil scientists call PEDs. Both words work. But the really important thing is it's between those PEDs where you find the pore spaces. That defines the soil's porosity. And it's those pore spaces that allow water to get into the soil. So if you don't have pore spaces, the water can't get in. It's just going to run off the land. Now the PEDs, these aggregates, are held together by clay, but also by an organic glue called glomalin. And here's a picture of glomalin under a scanning electron microscope. The soil has been dyed so that the glomalin stands out as green. Now this stuff is pretty hardy because it's not soluble in water, but tillage just tears it apart. Tillage destroys soil structure. And I'm going to show you some more photos of soil under the microscope for work that I've done. And actually I've got slides from here at Whiterock that we sampled soil here about 6-8 weeks ago, something like that. And this is a process. So we have a container that we're going to put it in. We dig a hole all around here. It's a lot of work, as the folks here at Whiterock will attest to. They helped out. And then we finally get to the part where we've got this little monolith of soil standing here undisturbed. And we put it into this container very carefully and then ship it off to a lab where they will infuse that entire sample with a resin. And once it hardens, they can cut it with a saw. They cut right through that sample container. So I never get those back because that's why it has to be in plastic, so they can cut right through it. And then they keep cutting till they get to about this thickness, and then they will finally put it on a glass slide, and then they will abrade and abrade and abrade till they get it to about the thickness, actually thinner than a sheet of paper. And then that thin section is observed and analyzed through a polarizing microscope. And I'm borrowing the one from the NRCS right now. I've got it here at Whiterock with me. And so this is what you see. Now these are soils, that you're going to see are thin sections that are from those Whiterock soils that we sampled. I've got 2 different soils here. We sampled 3, but I'm just going to show you these 2 for now. Ladoga soil is something that is it formed under trees, under woods, and it's a soil that the Whiterock folks are going to be doing some prairie savanna restoration in. And then the Marshall soil, these are both formed in loess, and this one was under no-till and cover crop. I believe it was corn. Not sure, it might have been soybeans. Anyway, these are both taken at a depth of 2 inches, 2 inches below the ground surface. This is the soil structure. Now this is phenomenal. We've got beautiful granules and crumbs. It can be crumb structure, granular structure in the very top part of the topsoil. But what's really noticeable is the amount of white space. Well, you know what that white space is? That is pore space. That is how water gets into the soil. And these soils have got at least 30% pore space. I'm going to show you some soils later from conventional tillage that are going to look very different than this. So that's granular or crumb structure. And then there's, as you go deeper in the soil, you tend to get blocky structure. These subangular blocks. Again, the white is pore space. And there's a lot of vertical pore space here for water to enter the soil. Here, and this is a huge pore, macropore. These are called macropores, all of these. So these are some really nice looking soils. Unfortunately, across much of the state, these soils don't look like this. So these are the consequences, some of the consequences of damaged soil structure. So you get this compaction because the aggregates or the PEDs are completely broken up. So you just have this sort of loose layer of powdery particles. And then when it dries out, you've got this crust on top. So water can't get through. So you end up getting ponding. And ponding is not good because it often, if it happens early enough in the spring, it prevents planting. It also will kill the plants if it sits there, the water sits there for too long. In addition, and we're going to talk about soil microbes here in a little bit, but they are aerobic. That means they need oxygen. They do not function well in saturated soils. They basically die, many of them. A lot of the bacteria live, but a lot of the other valuable microbes die. Okay, the second component that I want to talk about is soil biology. Soil is not inert. I think for many years, we just thought it was something to grow plants in, and it'll do fine. Just do whatever you want with it. It is not. It's a vital living ecosystem. It's teeming with soil organisms that keep it running smoothly. So the soil health practices like no-till and cover crops and others emphasize the ecology of the soil. And this is something new. Well, I'll leave it at that. This is the soil food web that, created. It's kind of like a food chain, but it's considered a web because it's not very linear. First of all, we've got their plants, which are their primary producers, and they will create proteins and carbohydrates by using the energy of the sun and carbon dioxide. And then it's the decomposers that then take that for mainly the bacteria and the fungi, which are able to decompose the large organic molecules in the organic matter, because plants cannot take up these molecules. They're too big. They need the decomposers to break them down into inorganic nutrients for plants. So they're extremely critical if you want to have a natural system and not completely depend on fertilizer. And then you have your grazers. Protozoa are single-celled, and they live off of the bacteria and the fungi and the nematodes. And the shredders are really critical because they take plant matter and they break it up, they shred it so that it's got a much more surface area and much more available for the other organisms. A couple of photos here are, a microscopic photo of the fungal hyphae, which are these long fungal strands that can extend for many feet. And they live symbiotically with the roots because they take carbon from the root, and then they bring water and nutrients to the root. And they can extend out, like I say, for yards and bring water and nutrients from a much larger area than that root hair by itself can do. So they greatly increase water and nutrient uptake. So fungi are very critical in a healthy soil. Unfortunately, as you can see, they're very fragile and they're strongly set back by tillage. The tillage destroys them. So there's very little in the way of fungus healthy fungus in a tilled soil. These are the little protozoan critters. They're single-celled and they're busy grazing off the bacteria off this root hair here. And I think they're kind of cute, actually. These are photos that I took when I was working. I set up a lab for soil health in my office with NRCS. Didn't know what the heck I was doing at first, but kind of had to learn. Here's a nematode, and nematodes kind of have a bad name because there are some that eat roots, and those are the bad ones, but there are actually 3 different kinds of nematodes, and they're good. This is a bacteria-eating nematode, and you can tell by its mouth here. This is where the mouth is. They all have different kinds of mouths, and he's just look at full of bacteria. Here's a springtail. And now we're talking about a little bit bigger organism. You could probably see this guy. He's longer than a pretty good sized part. This is, a pretty good sized sand grain right here. So you could probably see him with your naked eye. Okay, earthworms are critical. They can deposit so much of their castings, and they add so much organic matter to the soil because their castings contain 50% more organic matter than other soil. They basically work by shredding organic matter, and that facilitates the recycling of nutrients. So I'm going to run this tiny little video here. Oh, we've got some music to go with it. know if they can hear the music. See how he pulls that little leaf down into his hole. I think it's absolutely cool. And one of our soil scientists a few years back did a little study on worm counts, numbers of worms in no-till versus tilled fields. And, you know, they had 5 different holes for each of these. They had about a cubic yard or cubic foot of soil for each. So, you know, a chunk of soil. And they counted the worms, and I mean, there were between 20 and 30 worms in each site for the no-till, and fewer than 2, the average on the tilled soil. So no-till sites had 15 to 20 times more worms, which I think is just astounding. That means that 95% of the worms are being lost through cultivation. So, you know, it's when we were sampling that Marshall soil at Whiterock, it was really exciting because there were worms coming out every which where out of that sample. I think they all got out before we sent it to the lab. At least I hope so. Okay, so organic matter is extremely important to soil fertility, but it feeds the organisms. It keeps them alive. It improves the bed stability. And it also soaks up a lot of water. And that's becomes a factor when we start talking about global warming, because if we have droughts where it doesn't rain very much, you want to soak up every last drop of that water when it does fall. And so that's one advantage of having good amount of organic matter in your soil. It also improves soil tilth, like root penetration, aeration, and it sequesters carbon in the soil. I don't have time to talk about that, but that's something that has been in the news a lot for the global warming question. And I think this is amazing that soil contains more carbon than the atmosphere plus all the plant and animal life on Earth. It's almost hard to believe, but you know, there's soil across the whole globe. Well, how does soil lose organic matter? You know, erosion of topsoil probably is number 1, but intensive tillage, because what that does is it increases the oxidation of organic matter. So carbon is able to join with oxygen. Carbon, C, oxygen, O2 makes CO2. That is carbon dioxide. That goes up into the atmosphere. So it's losing carbon. Taking all the residue or most of the residue off of a field, that doesn't happen in nature, as I said before. And the excessive use of anhydrous ammonia, because anhydrous ammonia kills microbes. Also overgrazing in pasture situations. So if you don't have very much organic matter, you've got to use nitrogen fertilizer. You have to use, and it's used way too much in this state. It's over applied. It's applied in the fall. It's applied at times when most of it's running off into streams, and it kills the microbes. And you know what carries off to streams costs billions of dollars. I mean, the Des Moines Water Works spends millions of dollars to remove nitrates from the drinking water for the Des Moines metropolitan area. And I'm sure you've seen that in the news. So what tillage does to soil, rather than me explaining it, I'm going to show you a couple of videos, short videos, about a minute each, by Ray Archuleta. And Ray Archuleta worked for NRCS for a long time, and he took upon himself the mission of soil health, and he's very passionate. He came to Iowa many times. I got to know him, and he then eventually took a job with a private company where he could, you know, make more money. But these are some great videos, and the first one shows the aggregate stability. Aggregates that are stable in a no-till soil, and those that are not stable in a tilled soil. And the second one shows how water infiltrates these different kinds of soils under different practices. So here we go. Okay, so I've been told that the audio was very choppy, so you were able to see what happened in the first one, no-till soil. When rain hits it, it doesn't fall apart. I mean, it's very stable. And the other one, the conventionally tilled soil just collapses, falls apart, the aggregates, the glomalin disappears. And then the second one, the infiltration test, the one on the right, I believe, was the no-till soil, and water infiltrates almost, really rapidly. So very little runoff, nothing's running off the landscape or off the field. And the one on the left was the conventionally tilled soil. It's got a crust, it's compacted, and the water just can't get through. So what does it do? It runs down the hill into a stream. Okay, so these are some photos I took under the microscope. Again, this is about a ½ an inch from here to here across the slide. So you're looking at it at a tiny scale here. This is conventionally tilled, compacted soil. There's no structure. I mean, you cannot pick out an aggregate anywhere in here. It's just packed, individual particles. And the pore spaces are these little blue spots. That's it. So remember, the Whiterock soils had 35% porosity. This has probably got, I don't know, maybe 5%. Here's another one. Looks very different because it's a loam and it's got all these sand grains. So all this white and blue, those are sand grains. That's not pore spaces. The pores are these little cracks. This is a very highly compacted soil that was had high traffic by farm machinery for seed corn. And so most of these, most of these cracks are running kind of horizontally. There are very few vertical pores. So how does water get in? It doesn't. It just, very little of it gets in. Now compare that to, here's another loam soil. So we've got a lot of sand grains, the red, the blue, and the white. But the pores are these blue spots. So look at this, the size of this pore. And they're vertical. These are vertical pores. This is a no-till soil with cover crops. You've got abundant macropores. So that's the difference. I think, a picture is worth 1,000 words. You can talk about it, but when you see this, I think it's very convincing. And this is also very convincing. These are two fields in the same exact soil right next to each other. One under conventional tillage, disking and plowing, one under no-till. And look at the difference when it rains. The water is sitting here between the rows, can't get in. Some of it's running off into this ephemeral gully and down here into a creek. The no-till, there's no water sitting on the top. It's all gone into the soil. I love this photo. I was taken by one of our soil scientists in Northeast Iowa. So according to Ray Archuleta, and I happen to agree, we don't have a runoff problem. We have an infiltration problem. If water could get into these soils, we wouldn't have the amount of runoff we have. Now, cover crops, cover crops do so many things. I mean, there's a whole long list here, and I could have provided more. They protect the aggregates from raindrop impact. Raindrops, they hit the soil and they can do amazing damage. They're moving, more than 20 miles an hour. They break up compaction, increase infiltration of water. They add organic matter to the soil. They feed the organisms throughout the winter. They moderate the soil temperature, keeping it cool and moist. They suppress weeds early in the growing season. Here's cereal rye after corn. This is a multi-species cover crop, which farmers are being encouraged to use. And multi-species cover crops include plants called brassicas, includes radishes, turnips, rapeseed, and mustards. And they, as you can see here, this is a great guy from Ohio, Dave Brandt, showing off one of his radishes. These are fantastic at breaking up compacted soils because they kind of drill through the soil, and then when they rot, when they die and they rot and add organic matter to the soil. Cover crop usage in Iowa is, it started out going pretty much great, and then it has slowed down. In 2010, there were fewer than 50,000 acres. 5 years later, that increased by tenfold, almost 600,000 acres. And then in 2015, that was 2015. So it was about 2.6% of our cropland was under cover crops. 2017, we went up to 700,000 acres. The latest numbers, there's nothing official, but it's looking like we're closer to 4% by now. But you know, it's still only 4%, and so there really needs to be a lot of work done to get people on board with this. This shows the state and how, you know, this part of Iowa, Washington County just leads the state in the number of acres in cover crops. But, and here we are out here in Guthrie with Whiterock, but Whiterock is, their farms are all, their row crop is all no-till and cover crop. I'm coming here to the close. I just want to mention, you know, Practical Farmers of Iowa again and Midwest Cover Crops Council. They are both organizations that they can provide a lot of help to farmers. And Practical Farmers PFI has field days, which are wonderful. They also have mentor farmers for beginning farmers. So I can't say enough good about Practical Farmers of Iowa. And these are 5 tenets of soil health, and we've kind of covered all this already, but to show it all in one slide, you know, no-till, cover crops, crop rotation, leaving residue on the surface, and if you have livestock, doing it with managed rotational grazing where they're not left in one place too long. I'm not going to talk about these, but I just want to mention that there are these proposals on the docket in the Iowa legislature, and all of them include some form of soil health initiatives or soil health improvements. Unfortunately, they are all held up in the committee, and they've been that way since the spring. So I'm in touch with a guy named Steve Coletti who's keeping track of this. Hopefully there'll be some movement, but there are 12 states in the union that do have soil health bills in place. Nebraska, they don't have a bill, but they have something that recommends voluntary efforts. So that's kind of toothless, I guess, but it's better than nothing. Okay, so that's the end of my talk. I love this. That was put out by NRCS because this is the way I feel about soil. You know, if we didn't have soil, we wouldn't have life, at least not on the land. So thank you so much for listening. I hope you learned something. And, you know, I barely touched the surface of soils in this short webinar. So if you want to learn more, you know, please pick up my book. It's available a lot of places. You know, you can always order it through your local bookstore, you know, if you like Amazon. Some people don't, but it's also available. They actually have it on the Walmart website, I noticed. It tells, you know, it talks about, the first part of the book is about what soils are, how they form, how they were mapped in Iowa, a lot about, you know, the history of soils in Iowa. And then the second part is all about the human impact on our soils, the damage we've done to them. And it's also this new look at soils as a living ecosystem. And then I profile a number of farmers in Iowa who are doing things right, and finish with a chapter on climate change and the impacts on agriculture. So thank you again. Good night.
All right, thank you, Kathy. We're now going to move on to questions. As a reminder, I will launch a poll at the end of the webinar for feedback. So if you have time to stay a few extra minutes after questions, please fill that out. Our first question is from Lindsay. In your opinion, what is the largest barrier for farmers adopting cover crop use?
Yeah, you know, that's a wonderful question. There are so many different possible reasons. I mean, you know, farmers, you know, I know because I grew up on a farm, they tend to be conservative, and I don't mean politically conservative, but they're conservative because change is scary. You know, that's one reason. You know, a lot of them have invested in equipment for tillage that, you know, millions of dollars, because they were told to get big or get out by Earl Butz back in the 70s and things like that. You know, personally, I really think that the state, we need to have legislation where we subsidize farmers who want to get into cover crops but are afraid to do it because of the risk. There's not a lot of risk, but because actually after a couple of years, yields tend to increase. But for the first couple of years, there might be a slight decrease in yields. So farmers are nervous about that. But I think if there were subsidies that would support farmers, rather than us paying crop insurance, which basically, as far as I'm concerned, subsidizes crop failure. So why not get ahead of the game and subsidize people to do practices the right way? So that's a very loaded question. I mean, people are debating it all over the state, trying to figure out a way to get more cover crops on the field. Thank you.
Mhm. All right, our next question is from Tamara. Do you have any info on how soil health impacts nutritional value of food?
Oh, boy. I know that it does. I've seen films and things that talk about that. I'm not the best person to ask about that, I guess. Sorry. Yeah, I mean, for one thing, certainly organic food is going to be healthier. So yeah, I'm sorry, I just can't answer that question. But there's what's the name of it? There are a couple of films about soil that have come out fairly recently. One is the Soil Symphony, or Symphony of the Soil, and there's a more recent one. Can't think of the name of it. If you leave your name, I will contact you and give you the name of that film. It talks a lot about the health of food and soils. So Susan, if you could get her email, that'd be great.
Yes, okay. The next question is from Jennifer. What is your favorite soil type?
My favorite soil type. Boy, that's one I never really thought about. I like less soils. Because they're really easy on the hands. So as a geologist, we were having a texture soil all the time between our fingers. And if it's a sandy soil, it just tears your finger. You end up having hands that feel like sandpaper after a while. So, less soils are really nice. But, I'm also, I love paleosoils, which are buried ancient soils, because I'm a geologist. And so, the Clorinda, I love the Clorinda soil.
All right, and a follow-up to that from Jennifer is how many soil types are in Iowa?
Good question. There's over 400 soil series. I can't remember the exact number right now. So soils are mapped. There are soil series, and so there are soil associations, which might be 3 different soils: a soil on the hill slope, one on the shoulder of the slope, and one down below. And those are all 3 different soil types or soil series. The ones I showed you, the Ladoga soil and the Marshall soil, those are soil series here on Whiterock's property. Yeah, so it's 400 and some different soil series.
All right, and if people aren't looking at the chat, some people have recommendations on movies and videos they can watch about that nutritional value question. Excellent. And there's one more. I think we have one more. Is there a state soil of Iowa?
There absolutely is. It's called the Tama. It's Tama soil. That's the soil series. It only occurs in the eastern half of the state, so we don't have it out here at Whiterock. But it is a soil that formed under prairie, and it's originally had it still in places has a topsoil that's almost 20 inches thick, and it's black. Beautiful loess soil formed in loess. Yes, good question. Tama silt loam. If you want to see it, you can go to the Science Center in Iowa, because they actually have a block. Can't think of the right word I want. A monolith of the actual soil. I think it's coated in something to keep it from drying out. But yeah, that's a good question. Thank you.
All right, and one more from Robert. Can you recommend any resources applicable to Wisconsin soils?
Oh. There's not a book similar to mine that's written for the lay person that I know of. Again, get the email and I will research that and let him know, because I don't know right offhand. Sorry about that. And what am I, 3 for 5?
That's answers. All right, that's all the questions we have right now, and we're at a minute left, so I'm going to launch our poll. And I just want to thank everybody for coming once more. And I'm going to put my email in the chat if you have any additional feedback you want to provide, or you want to get in contact with Kathy. She can also put her email in there as well if you'd like. I'd love for all of you to come out and visit Whiterock and see your faces in future programs, or perhaps just your names on a screen. Although this webinar was free, we would like to recommend making a small donation on our website if you're able, so we can continue to provide educational opportunities like this one. Thank you.